How do you detect an approaching object using a sensor? Let's try an obstacle avoidance sensor. This is part 26 of the KEYESTUDIO 3701 sensor kit, the obstacle avoidance sensor module. I use the fritzing software to show you how to connect everything. Here's what you'll need: an Arduino microcontroller, preferably the UNO version or similar, a 400 tie-point breadboard, a USB cable, the obstacle avoidance sensor module, 4 to 10 jumper wires, and a small flathead screwdriver. Place the obstacle avoidance sensor on the breadboard towards the middle, connect the pin labeled G to ground, connect the pin labeled plus to 5 volts, connect the pin labeled out to digital pin 8, and connect the pin labeled EN to digital pin 9. Now here is the real version. Here are the key features of this sensor module. The obstacle avoidance sensor is at the top. It is split between a transmitter and a receiver operating on the infrared light spectrum. The P LED indicates the circuit board is receiving voltage. The S LED turns on when the sensor reading exceeds the threshold value. The NE555 chip is a precision timing circuit operating in astable mode. This means that the frequency and duty cycle are controlled independently with 2 external resistors and a single external capacitor. The EN pins allow you to enable or disable the circuit with code or logic when the jumper is not bridging both pins. Above the EN pin, the frequency trim pot uses a 10 kilo ohm variable resistor, and so does the sensitivity duty cycle trim pot. Next, grab the USB cable, connect it to the Arduino, and then connect to your computer. We'll use the Arduino IDE software for programming the Arduino UNO. Upload the following 14 lines of code. Open the serial monitor and observe the values from the sensor. The logic received from the sensor is a binary response, meaning the value received is either a 1 or a 0, on or off, high or low. This sensor functions much like an ultrasonic ping sensor, except it uses light instead of sound to detect an object. Use the flathead screwdriver to rotate the frequency and sensitivity trim pots to observe the difference in response or distance from the sensor. This sensor is typically used with a robot ground rover to avoid obstacles along its path. Once you get the hang of it, come back and join us for the next module.